Hello, my name is Brendan Bova,
And my name is Amanda Smith.
and we are here to talk to you about the Chicago Energy Report from 2010.
This data set looks into a little bit of how location and month and housing size and all of these other variables affect the amount of energy that is used in different locations. And it uses a lot of different variables to describe these things. It uses kilowatts per hour, therms, and also housing size, type of housing. Uses a lot of different variables. It's a very extensive data set, and is very interesting to look into, and we decided to use it, and we are very interested in what we would find. This first graph here shows the amount of each type of building. There were four main different types of buildings: the commercial, the industrial, and residential. And then there were also some that were not labeled. And so as you can see in this graph, it shows that the main type of building was residential in Chicago, and the second most common type was commercial, with very few industrial and very few ones that weren't labeled. This is just a quick summary of all of the variables. As you can see, it's very cluttered because there were a lot of variables, and there were 73 different columns that showed different things, but we definitely had to reduce the amount of variables in order to focus in on what we wanted to look at. And this is just a list of all 73 variables. Obviously, when we went into the cleaning stage of our project, we reduced it to about 10. So this was a lot to look at first, obviously. And then this shows the head command. So it shows the first 6 rows of data and a couple of the variables that were included in this data set. And it just gives you a little look into what our data looked like and what we needed to do with it.
And now we will look at a graph over the total population versus total units. And as we can see, as population increases, so do the units, which is what we were to expect. And then next we have a box plot of the 0 kilowatts accounts. Now we just wanted to create this to try to figure out our data, but this really didn't end up benefiting us in the long run. But this is what you have to do when you're trying to look at new data. And then finally on the home page, we're going to look at a graph with the total population versus total kilowatts. So as the total population increases, so does the total kilowatts. It doesn't increase dramatically, but it's definitely there. And then there's a linear line that kind of helps us see the trend. As population increases, so does the kilowatt usage.
And this is the part of the project that we did a little bit of cleaning into the data. So you can click on each of these links to view the cleaned, the uncleaned, and the exploration document that we looked into. So this first chart is what we just looked into, but this one is the one that we made after we had cleaned the variables or the data. So it shows fewer points and more concise data, but it still shows the total population and total kilowatts with the same trend as we saw previously. And then this just looks into how our data was cleaned exactly, and it was a pretty extensive process since we started with such a large data set. So we pretty much wanted to reduce the amount of columns so we could focus in on exactly what we wanted to look at, which was the total kilowatts, population, community size, and building type. So we reduced it to about 10 variables. And then we wanted to make sure that the data that didn't have any data in the ones that were blank, we filled them in with NAs instead of just being blank. And we also wanted to make sure the data was concise. So we decided to change things that were kind of out of the ordinary, like column headings that had underscores instead of periods. We changed those so they would be consistent, and some of the variables like less than 4, we changed it to less than sign and 4, so it would again be consistent. And then if you scroll down a little bit on that, it shows just that scatter plot we went into, and again, that's just the clean version. And it shows the same trend that we'd seen previously, which shows that it is true that as total population increases, so does kilowatts.
And then now we have our abstract, which basically includes everything we're talking about in this presentation. But if you want to have a more in-depth look, just hop onto our website and look at it. But then finally, we have our fancy models that we made regarding our data. Our first model is a cart model, and it is basically we're looking at most of our data. We only chose a few variables to look at, and it is putting it into whether or not it believes it would be a residential or commercial building. And as we can see that the greater the kilowatt usage, it tends to be a commercial, while the fewer kilowatts tends to be a residential place. The most important variables in this graph are total kilowatts, total population, and the building type. What's really intriguing is that most of our data lies into the residential aspect of 66%, with the population greater than or equal to 10 and being greater than 30,000 kilowatts. So it's just a neat graph to look at if you want a concise, quick understanding of our data. And now we have a random forest graph that we created. This helps us visualize what variables are being used the most in our data. So the total kilowatts by square feet and kilowatts maximum 2010 are the most used. So they're the most important variables. Meanwhile, the building type is actually the least important variable, but I find knowing the building type to be rather important, especially in the cart model, so we get an idea of what is happening. Then we have our regression information, which basically has a whole bunch of numerical data, which is neat to look at if you want to know specifics, as in residuals, coefficients, R squared, and if you want to know like a linear line that's throughout our data, it is going to be there. Finally, we have another graph relating to our total population and total kilowatts being used, but this one is a predictive model. And as you can see, this line is curved and it's trying to predict what, basically, if you're at 5,000 population, what would you be at kilowatt wise? Is trying to predict information for us. So that is all we have to present.
And in the future with this data set, I think it would be really interesting to look into the possibility of how different neighborhoods could affect the amount of kilowatts per hour used. But since neither of us are Chicago natives, it was difficult to know what part of Chicago each neighborhood was in, but I think that would be a super interesting thing to look into. And but we just decided to focus on this part for our presentation.